Scholars, check it out. With all this great work we're doing today, we're going to be thinking about finding sums by the use of an algorithm. This is probably what we see most commonly. It's really no different than what we've been doing. It's just kind of modeled different, right? It's that idea of equivalent. I just really think this is a great word to have, equivalent. Sorry, that's a U, which really just means that something has the same value, but it looks different. So we're going to be doing the same work we've already done with how we find sums. We're just going to do it in a different way. Like, it's just going to look different, but it's really the same thing. And it is this idea that, like, when I'm given some add-ins, right? We remember that word add-ins. Let's find a good color for this. Like 53 and 129, let's just say, right? Given these add-ins, how can we solve this now using an algorithm, right? So 53 plus 129, let's look at that. So 53 plus 129. So we're going to solve this using an algorithm today. And that's just stacking it up by the place value instead of modeling. So when we do that, there you go. There's kind of the first step. We just want to stack our numbers with place value, PV by place value. And I typically like to find my larger number to go on the top. It actually doesn't really matter, but it is a way we like to organize it. And I think it makes it a little more simple when it comes to like finding and lining up place values of other numbers. So I'm going to take 129. I'm going to write that there. And then I'm going to line up 53. And I know that my 3 is in my ones place. So it's going to go under the 9, which was the ones place. And then my 5 is here. So if you want to think about what we're doing here, it's very similar to the model, right? It's the ones, the tens, the hundreds. But now, as you can see, I'll just kind of pretend, instead of modeling it with pictures, or our base 10s, I shouldn't say pictures, base 10s, we're just going to use the digits to kind of think about what it means. Okay, so that's really what we're doing. I hope you can kind of see that overlap. I'm just like pretending there is a model there. So let's do that work, right? And I'm going to actually go on both sides so you can see how that works. And I already feel like this got a little sloppy. So let's change pages real quick. 129 plus 53. All right, let me really set this up for you. So 123 plus 59, right? So here it is that we're using the algorithm. And over here, not that would be a 1. I would run out of space, excuse me. Over here is where we're going to model at the same time, so you can see what we're doing, like how these are similar. But this technique over here, this algorithm, I'm not using the model. All right, so if I was to model my ones place, I have a 1, 2, 3, 2, and a 1. So there's the hundreds, and then I line up my 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5. Okay, so there would be the model. But over here, I'm just going to start. Ooh, we're not going to move that. Ooh, boy. We're going to start in our ones place, like always, right? I always said start in your ones place. And if we look here, we just have 9 ones plus 3 ones. So that would be like 9, 10, 11, 12, right? So that'd be 12. But as we know, I can't put 2 digits in one place value. This is the ones place. I can't put 2 digits in there. It doesn't work. So we think about what that means. If I have 12, that actually means I have a 2. I have a 2 in the ones place. And then we regroup with that extra 10 like we did over here. And let's look at how that works with the model, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my group of 10. And I plop it over here, and I have 2 left. So you can see this model and this algorithm are working in the same way. It's just if I use an algorithm, I'm not drawing the model out. And this is a preference. It's whatever you're into. Sometimes as we get to larger numbers, an algorithm might be a simpler way to set up. But it doesn't mean there's a right or a wrong way to do this. Both of these styles work. Okay, so now we're in our tens place. So 5, 6, 7, 8. Okay? And if we were to model that, let's look. 1, 2, 3, 4, 5, 6, 7, 8. What do you know? Okay. And now the hundreds place, which is a 1. And if we go over here and count, 1. So you can see we got the exact same sum, 182 and 182. So I hope that made a little sense. I know there's a lot going on the screen, but I hope it makes sense of like how this algorithm works and what we would be doing if we were modeling at the same time. So you know what I say, practice, right? Let's just keep going at it. Let's figure it out as we go. So let's take 253 and we're gonna add 89. So this time I'm just gonna use the algorithm, but if you want, you could model it first and then solve it as an algorithm and compare your answers and see. And maybe we will do that. Let's just see. So first I'm gonna stack. So 253 and 89, okay? So I'm gonna start, and again, I'm just gonna kind of, so we think, so you can see, let's start my ones place here. So that's 9 plus 3, so 9, 10, 11, 12. So once again, I'm stuck with a 12, which are 2 digits, but I can only put one of those digits in the ones place. So the 2 is in the ones place, and then I regroup that 10 over into the tens place, okay? So now we add our 10, so that's 8, 9, 10, 11, 12, 13, 14. So again, 14 and regroup, and then 3. So this would be 342. That would be my answer, 342, right? And if I want to just kind of jump back to what we did in that tens place, right? Just so that makes sense of why like the 4 was here, right? Because I said 14, but we put the 4 in the tens place, which is true because there's 10, right? We're working with our tens place, and there's 14 of them, which really, if we counted by tens 14 times, 10, 20, 30, 40, 50, we would get 140. And if you look at that number, well, look what digit's in the tens place, the 4. And that's why there's a digit here. And then we had to take and regroup and put one more over in the hundreds, which is what we did right there. So I just want to see if that makes some sense, right? Grab onto what makes sense. Work with the techniques that work, and then practice everything. So don't feel like if this is confusing, like, oh my gosh, what do I do? You're fine. We're good. Let's do another one. 259. Let's mix. I'm gonna throw 1,000 in here. I feel like we haven't done much with the thousands yet, and this is why I say with an algorithm, when numbers get larger, it's a simpler way of setting it up, right? Because if we use the model, then we have to start drawing all these pictures of thousands, and things can get a little crazy. So again, I'm going to stack and then start in your ones place. Always 9, 10, 11, 12. Wow, I feel like that's been the case every time. So 2 in the ones, carry over a 10. So 7, 8, 9, 10. Wait, sorry. 7, 8, 9, 10, 11, 12, 13. Carry it over. 8, 9, 10, 11. Carry it over. And there's my answer, 2,132. So you can see that this is that idea of efficiency. Like, I'm getting through this problem quicker. Now, speed doesn't mean anything in math, so I don't want you to feel like, oh, well, I better do this so I'm quicker. It's the technique you're most comfortable with. If you're really comfortable with modeling, you're going to be able to solve this quicker than an algorithm through your models. So again, you use the technique you know well, but then don't forget to practice the other ones so that you can get stronger at them and then apply them. Because we'll just see, again, if we model this out, we might end up with a lot of work and it takes a while, but hey, let's do it. I'm just gonna model. Let's go for it. Woo, feeling wild. Let's model. So this case, I have ones, tens, hundreds, thousands. So I gotta think about how I'm gonna model that. Ones, tens, hundreds, thousands, thousands. Okay. Whew. Okay. 4. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, and then thousands. And model how you want for thousands. I use circles. That's just the way I do it so that things don't get confusing. I'm actually not going to sit here and try to draw that like 3-dimensional cube that actually is 1,000, right? I'm not going to worry about that. I just do circles. It's quicker. All right, so 359 would be the other number that we're adding in. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, and 300s. So again, as you can see, like we're modeling, this works, we can do it. Let's count up the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a group of 10. Let's throw that over here. That leaves me with 3 left. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're good there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a group of 10. So that makes a new 1,000, and I got 1 left. And then 1, 2, 3. All right, so I got 3,193. All right, so let's algorithm this one and see. Hopefully I can remember. 2834. So 2,834. And we're adding 359. All right. So 359. Okay, so algorithm, same, right? Same problem, different technique. So always start in your ones place. So 9, 10, 11, 12, 13. Okay, carry that 10 over because it was 13. 5, 6, 7, 8, 9. 8, 9, 10, 11. 2 and a 3. So I got 3,193. So 3,193, 3,193. So as you can see, we solved this using both techniques, but again, this is the algorithm. So give this a go, try it out, see what you think. There's going to be some problems for you to work on with assignments and quizzes. Use the technique that works best for you, but again, practice the one that feels like, oh, I'm not quite sure yet, right? If you're great at modeling, model it first, and then try an algorithm and compare your answers like we did here, right? Do it that way. But eventually try to get yourself to this place where maybe you're feeling really comfortable with using an algorithm. All right, as always, I thank all of you for your hard work. And let's do this again soon, yeah? Talk to you later.